Hello, Mr. Burrell here. We're in Unit 10. We're talking about solving quadratic functions. We talked about the square root method in the last video, solving a quadratic function by square root and kind of the scenarios associated with that. Today we're talking about finding zeros. If you don't know what that is yet, that's okay because we haven't talked about it. We're going to talk about what I mean by when I say zeros in association with a quadratic function. And we're going to talk about a property that can become really helpful in the next coming lessons to help us to solve quadratic functions. So let me get in here. Objectives by the end of class today, by the end of this video, I hope that you're able to understand what a zero is and find a zero using the zero product property. Lots of zeros in there. If you're like, Mr. Burrell, what in the world are you talking about? That's okay. We're going to discuss it right now. So what is a zero? When I say zero, find the zero of a quadratic function, what am I talking about? So in mathematical terms, a zero is a value for the variable, usually x, that will make the function equal 0. So in the standard form of a quadratic, I'm given this, ax squared plus bx plus c, and when I put that into a function form, it's equal to 0. Ax squared plus bx plus c, and on the other side of this equal sign, I have 0. So when I ask you to find the zero of a function, it is the number for x that would make the left side of the equation equal 0. So in other words, if I were to look at this function, and I'm not going to find the zero here, but when I say find the zero of this function, I would say I'd be trying to find what value would I put in for x to make all of this equal 0. Okay, that's what a zero is. What am I going to put in for x that would make the function equal 0? That's what we're going to talk about. That's what I'm talking about when I'm finding a zero. What do I put in for the variable to make this side of the function equal 0? Okay, so one method a zero can be found is by using the zero product property. So this is the second one of our objectives, that you understand what the zero product property is. The zero product property says if a times b is equal to 0, so if I have a, whatever that may be, times b, whatever that may be, and it's equal to 0, if I have a function like that, either a has to be 0, b has to be 0, or both. This means that when two terms are multiplied, if one of them is equal to 0, then the multiplied answer will be 0. So say a is 5 and b is 0. Then 5 times 0 is 0. Say a is 17 and b is 0. Well, then 17 times 0 is 0. Well, maybe a is 0 and b is 732. It doesn't matter as long as one of those terms is equal to 0. When I multiply them together, it gives me 0. What if both of them are 0? What if a is 0 and b is 0? Well, 0 times 0 is 0. So it works. It's good. So again, the zero product property says if I am multiplying two or more terms together, if one of those terms is 0, then the answer when I multiply them together will be 0. So 3 times 0 is 0. 0 times negative 42 is 0. X times 0 is 0. That's what the zero product property says. Okay, so we're going to watch a quick little video. Any of you ever seen Hidden Figures? It's about this genius little mathematician girl. Anyways, it's about rocket ships and stuff. It's pretty cool. We're going to watch a short little clip from Hidden Figures because it talks about the zero product property briefly in it. Bringing in what we've talked about in the last unit about factoring quadratics. So listen here. You might not understand what she's saying yet, but you will. So let's see here.
If the product of two terms is 0, then common sense says at least one of the two terms has to be 0 to start with. So if you move all the terms over to one side, you put the quadratics into a form that can be factored, allowing that side of the equation to equal 0. Once you've done that, it's pretty straightforward from there.
Oh, I love the teacher's face after she says all that. She's like, after that, it's pretty straightforward from there. And he's like, what? Because they're in a class with like all these high schoolers, and she's like 8. If you've ever seen this movie, you've probably heard her say that and be like, man, she's a genius. How'd she know that? What's going on? That's crazy. That must be crazy math. That is the math that we're talking about right now. It's not as crazy as it seems. So the line that she says in there, she says, if I put the quadratic in a form that can be factored, and I write it in factored form, like this, so if I have a quadratic in factored form, she says that the product of two terms, if the product of two terms, so these two terms right here, I have this term in parentheses and this term in parentheses, if the product of two terms is equal to 0, say this is A and this is B, then common sense says that one of the terms has to be equal to 0 to start with. So then she says she puts all the quadratic on one side, factors it, and then we go from there. So that's what we're talking about here. She says if these two multiplied together is equal to 0, at least one of these terms has to be equal to 0 for that to be true. Okay. So again, one of these binomial terms would need to be 0 for the equation to equal 0. So to find what the 0 would be, each binomial is set equal to 0. So I have x plus 6 times 2x minus 1 equals 0. So either x plus 6, this term has to equal 0, or 2x minus 1, this term has to equal 0. So x plus 6 has to equal 0, or 2x minus 1 has to equal 0. Then, this is really pretty straightforward to solve for x. If I wanted to solve for x here, I'd subtract 6 on both sides, and I'd get x equals negative 6. If I wanted to solve for x here, I'd add 1 on both sides, and I'd get 2x equals 1. And I'd divide by 2 on both sides, and I'd get x equals 1/2. So again, when I have two factors that are being multiplied together and equal to 0, common sense, like our friend, I can't even remember her name in Hidden Figures right now, like she says, common sense tells us that at least one, or both of these factors has to be equal to 0 to start with. And that's what I did here. Set both of those factors equal to 0, solve for what the x value would be to make those terms equal 0. Okay, so yes, therefore the two zeros, so I'm finding the zeros of this function, the two zeros, or the two solutions, are x equals negative 6 and x equals 1/2. Okay, let's do this. So here's some examples. These are in your guided notes. If you've chosen to download the guided notes and follow along with me here, these are in there for you. If not, just follow these down. So I have two factors here, x plus 4 times x minus 7, and over here I have x minus 10 times x minus 5, and both of these are equal to 0. So the zero product property states that if I have two terms being multiplied together, at least one of those terms has to be equal to 0 if when I multiply them together, my answer is going to be 0. There's no other way. So I'm going to set x plus 4 and x minus 7 equal to 0 and solve for x. So x plus 4, I subtract 4 on both sides and I get x equals negative 4. Here I'm going to add 7 on both sides and I'm going to get x equals 7. So those are my two solutions. Those are my two zeros. Those are the two values that satisfy this equation. Let's double check and make sure that they actually do. So if I plug negative 4 back in here, I'm going to have negative 4 plus 4 times negative 4 minus 7 equals 0. Let's see if that's true. Well, negative 4 plus 4 is 0. And then negative 4 minus 7 is negative 11. What's 0 times negative 11? 0. Anything times 0 is 0, so that's good. That's solid. Like we mentioned in the last video, every quadratic function is going to have two solutions, or two zeros, so let's check 7. 7 plus 4 times 7 minus 7 equals 0. Not 70. I don't know where that came from. That would be 11 times 0, and that indeed is equal to 0. So my solutions are negative 4 and positive 7. Let's do the same thing here. If I have these two terms being multiplied together, that means one of those terms, or both, has to be equal to 0. So x minus 10 has to be equal to 0, and or x minus 5 has to be equal to 0. I can go ahead and add 10 on both sides, and I get x equals 10. I'm going to add 5 on both sides, and I'm going to get x equals 5. So in this case, those are my two solutions, or my two zeros, for this quadratic function. I have these two factors. When they're multiplied together, one of the factors or both have to be equal to 0 in order for them multiplied together to be equal to 0. That's the zero product property. Okay, Let's do ones that look a little bit more intense here. So now I have, instead of just x minus 4, I have like 2x minus 4, but the process is going to be the same. One of these factors, or both of them, need to be equal to 0 if I have this all being equal to 0. Because when I multiply two numbers together to get 0, one of them has to be 0. So 2x minus 4 has to be 0, or 3x plus 1 has to be equal to 0. Let's solve. I'm going to go ahead and add 4 on both sides, and I'll have 2x equals 4. I'm going to divide by 2 on both sides, and I'll get x equals 2. That's my first one. Here I have 3x plus 1, so I'm going to subtract 1 on both sides and get 3x equals negative 1. I'm going to divide by 3 on both sides, and I'm going to have x equals negative 1/3. So those are my two solutions, or my two zeros. The two numbers that if I put them back into these factors, back into these terms here, it would make at least one of those terms be equal to 0. And 0 times anything is equal to 0. So that's how I'm using the zero product property to find these solutions, or these zeros. How about this one? If both of these multiplied together equal 0, then either 5x plus 2 has to equal 0, or x plus 11 has to be equal to 0. Let's solve for x. I'm going to subtract 2 on both sides, and then I'll have 5x equals negative 2. I'm going to divide by 5 on both sides, and I'm going to have x equals negative 2/5. So that's one of my answers. That's one of my zeros. One of my solutions is x equals negative 2/5. Here I'm going to subtract 11 on both sides, and I'm going to get x equals negative 11. So my two answers here are x equals negative 11 and x equals negative 2/5. And again, when you plug those numbers back in here, if I were to plug negative 11 in for both of these x's, or negative 2/5 in for both of these x's, my result will be 0. Okay, let's do a couple more. These are the last two on your guided notes. So right here, I have a term a, which is this x term. I have a second term, this x plus 8, and this third term, which is 6x plus 4. So previously I just had two factors, that's fine. If I have three terms all being multiplied together, again, as long as one of them is equal to 0, then the solution will be 0. So if I had like 0 times 6 times 7, that's equal to 0. If I had 14 times 0 times 3, that's equal to 0. If I had 703 times 16 times 0, that would still be 0. As long as one of those terms is equal to 0, then the whole solution is equal to 0. So here, I'm going to set each of these three terms equal to 0. So I have x equals 0, x plus 8 equals 0, and 6x plus 4 equals 0. Well, this is kind of handy. This one's already solved. So if x equals 0, that's one of my solutions. For x plus 8 equals 0, I'm going to subtract 8 on both sides, and I get x equals negative 8. That's one of my solutions. If I have 6x plus 4 equals 0, I'm going to subtract 4 on both sides, get 6x equals negative 4, and then divide by 6, and I'm going to get x equals negative 4/6, or if you reduce that to a fraction, a simpler fraction, that's negative 2/3. So those are my three solutions. And again, if you want to double check yourself, if you want to check your work, put those numbers back in for x to make sure that they actually will give you a result of 0. For example, if I put 0 back in for x, I'll have 0 times 0 plus 8 times 6 times 0 plus 4. So that's 0 times 8, 6 times 0 is 0, plus 4 is 4. 0 times 8 times 4 really is 0. And I'm not going to put in the rest of these. You can put in the rest of those if you want to check. But as long as one of these terms is equal to 0, and these values right here, putting in for x, will always make at least one of these terms equal to 0. So when I multiply them all together, I get 0 as my solution there. Okay, how about this one? I have 4 times 2x minus 7 times 5x plus 3 equals 0. I have three terms again, but this term will never be 0. 4, there's no x attached to it. 4 will never be 0. It will always stay as 4. But I still have these two other terms, so as long as one of those terms is equal to 0, when I multiply them all together, then the solution will be 0. So if 2x minus 7 is equal to 0, that's a solution, or if 5x plus 3 is equal to 0, that's a solution. So let's do it. Let's solve for x here. So here I'm going to add 7 on both sides, and I'll have 2x equals 7. Then I'll divide by 2 on both sides, and I'll get x equals 7 halves. On this one, if I subtract 3 on both sides, I'll get 5x equals negative 3. Then I'll divide by 5 on both sides and get x equals negative 3/5. And those are my two zeros, or my two solutions. The two values for x that if I plug them back into this equation and multiply everything together, it will give me 0. So that's what I'm talking about when I talk about zeros. That's what I talk about when I'm talking about the zero product property. That's what the lady in Hidden Figures was talking about when she says the product of two terms, if it's equal to 0, common sense says that one of those terms has to be 0 to start with. Now you're as smart as the lady in Hidden Figures, maybe close, or at least the 8-year-old lady in Hidden Figures. So that's the end of this lesson. The things that I wanted you to be able to do is understand what a zero is and find a zero using the zero product property. We're finding solutions to quadratic equations when those quadratic equations are in factored form. In the next lesson, we're going to go the extra step and use what we know about factoring to continue to solve equations like this. So I hope that was helpful. I hope you enjoyed that. Especially I hope you enjoyed it as much as I enjoyed making it.